Welcome everybody to Robot Builders Night Virtual for September 2nd, 2025. Tonight we'll do the usual presentation and then open mic with any questions anyone has. Just a reminder that if you don't want to be seen or heard, mute your microphone and turn off your camera. So to get things going, we're going to start off with Mike with a presentation on an update on his robot.
Yeah, so I've been continuously working on it, and I got it so that it can traverse around the house. It's pretty rough and needs a lot of tuning, but it actually tries to squeeze between obstacles and stuff. And for that such a big car, an obstacle is a hallway, the two walls of a hallway. So, and I added a like a bumper sensor, like my multi-point time of flights 8x8s. So I put 3 on the front bumper. So hopefully I can get a good idea of where obstacles are close to the ground, so I can avoid them where the LiDAR won't see them, and also to help with the cone approach. So, I'm going to show you the okay. So this right here is the RViz, and you can see, can you see the screen?
Yes.
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 Yes. Yeah. So you can see my robots here, and the red line, like if I turn off, if I turn off the laser, the red line goes away. If I turn off the map, you get rid of some of the obstacle noise. And then the laser is the red line there, and then those dots there are my my sensors from my bumper sensors. And if you look at it from the side, you see they have height and depth and everything. So it can see the stuff in here, but also it can see the ground. So I got to figure the ground part out, because you can see the ground, and but the weird thing is I'm seeing some odd speckles above the ground, right in this area here, and there's nothing there. So somehow it's some reflections. It must be seeing some reflections off the ground and thinking it's an obstacle. So, but I just got to work.
Did Mike just? Okay,
Huh?
there he is.
We just lost your audio a little bit there, Mike.
Right.
Okay, so you can above the ground. There's nothing there. You can see
mean the purple or dark kind of bluish dots? You mean? There's some blue dots that are high up.
The dots over here is a wall, but these dots here is right above the open ground area.
I'm having trouble finding your cursor. I don't know if your cursor is being shown.
Oh, it's a pretty small cursor on my screen. Okay, so I'm gonna get the sensors working better. Something's going on, and I like I said, I haven't had time to really try them. I just put them on and said, hey, they work. Because if I go in here and if I turn on the laser again and look at the top, so you can see that the wall here like, can you see my pointer now, or?
No, we can't see it.
Yeah, can't see it.
Must be way too small. Ha! Crazy. Okay, well, but it looks like the speckles line up with the are pretty close. So I've looked at it, you know, a lot, and they're pretty close. So if I go in here and I turn off this noise, like if I turn off, I got 3 sensors on the bumper, a front one and a left one and a right one. Yeah, so we'll just go into here. I took these off of my obstacle detection, which is the map. And so it's just in the LiDAR, because the other one has some speckles in weird places, and I got to figure out how to deal with that. And then this right here is the cone. And if you look at
what is the cone? Is it
the yellow dot? The yellow dot.
Okay.
Right.
Okay, out in the hallway there.
Yeah.
So you can see it in the hallway. So from that camera's view. So and then my now the phone camera here, so I can sort of record the movement a little easier. So I can just use the fancy tool to set a goal from RViz and say, okay, I want you to go right here. And so you can see that it's now I don't know why it goes straight and then makes a turn instead of going at an angle, but
it's trying to avoid those high price range area.
Yeah. So so it found it. Yeah.
Did it hit it with the bumper?
Oh, it's not that smart. It just rammed it because it's yeah. So that's sort of the show and tell. It has to there's a lot more work to go. I'm gonna turn this off, and I'm going to stop sharing. Well, I need to. It's acting like it's getting stuck, and for some reason, there's a spin behavior that the example code or whatever I have it tries to say, hey, I'm stuck somewhere, I need to spin. Well, cars can't spin, so it's really freaking out. I'm going to stop. And all right, so I'm going to stop sharing because that's as much as I want to share.
Well, that looks like a gold star to me.
That's what I would say.
Yeah. So it does move. It steers. It sort of goes where you tell it to go. At some point, I want to say, okay, wherever that yellow dot is, the cone, go to it. So
now I have a couple of questions on your obstacle avoidance code. You said you were picking up the ground. If you ignored, I know it's got all the nice array, it's an array and not a line, but if you ignored, say, the bottom two rows, would that be a solved problem?
Oh, well, inside of the navigator, you can say ignore obstacles this far from the ground. So I set it so that it ignores obstacles, about that far from the ground.
Okay.
50 millimeters. And when I looked at it, it wasn't seeing those, but there's some speckles just speckling in the air above all that, and those were being detected as obstacles because they weren't below the ground.
Yeah. Are those by any chance just the maximum range of the sensor?
No. It's
No?
something, some reflection. I
Okay.
gotta, I'm gonna figure it out.
Okay. The other thing, a lot of times people have a lot of problems similar to this with ultrasonic, because ultrasonic's a cone, and so the trick is to take instead of having the ultrasonic point perfectly forward, they have a slight angle so that it's pointed slightly up. So I just wonder if that's of any use to you in this situation.
I'm not sure, but because I figured that these sensors, they point down and point up, and they got 8 sensors at different levels, at different things, and so I should be able to ignore stuff that's below the ground and stuff.
Okay.
Mike, is that LiDAR you're using that we see?
Okay, let me bring that back up. Let me start my.
Or the sensors, the LiDAR.
Let me bring this back up. I repositioned my robot so it's quote normal. Okay, and then let me share this screen here. Share screen again. Okay, so the again I'm going to shrink that down. So the map is just is taking the laser scan. This is the laser scan. I'm turning it off and turning it back on. So that's seeing stuff in the room at the height of the LiDAR, which is 200 and something millimeters, 300 millimeters above the ground. And then this is my front sensor here, my front time of flight sensor, and you can see that it has so you can see that it can see the wall, like you can see that array of rainbow colors, and it's basically seeing the wall where the LiDAR sees it right before the hallway entry is.
Okay. Wait a minute, Mike. Other Mike, the sensor that Mike W is using, it's not a line. It's actually an array of dots. And so he's got, if you look at this, there's the highest ones, which are the blue ones, and the next one, which are green, and the next one, which is white, and then the next one, which is red. Then it looks like he's got another green, and then an orange, and then a yellow. So, those are all rows of pixels in his single array, his LiDAR array. So I just wanted to make that, because he might not understand, Mike, that's really what's going on here. Okay, so that's why what Mike's saying is, the front one, middle of the array points straight forward, but the other ones have a slight angle to them. So that's why he gets a wall of readings.
So the 4 top horizontal rows are tending to hit the vertical wall in front of the robot and bounce back, and the other 4 appear to be hitting at different places on the floor and bouncing back.
Kind of. That's what it looks like.
Yeah, that's what it looks like to me.
Yeah, so you can see at this angle here.
So my question is, what is the technology of those arrays? What kind of sensor is he using for those? I'm just curious.
What's the name of it?
Oh,
what is it? What technology is it? Is it your time of flight? What kind of sensor are they?
Lasers.
Laser, yeah.
Laser?
Yeah.
Okay.
I mean, it's a solid state. It's just so it's the
But it's not your LiDAR that spins on the top of your robot, though,
right?
No, that's the big red rectangle.
Right, okay.
Thing.
Yeah, that's a big red thing. And then this other one's an array of sensors. well, it's one big sensor, but it acts as a big array.
Okay, well, thanks.
It can detect 64 different object or different locations on here, 8 by 8. And then he was saying that the like on the very back there, you can see things that look flat. So they're the wall and the LiDAR just sees a line. And then there's an opening with the LiDAR where the hallway is. But on each side of the hallway, there's a wall. So you can see 2 flat surfaces of wall stuff with the different color dots. And so those are 2 walls, one on either side of the hallway from the bedroom's point of view. And then really close to the robot, you can see the orange ones, and that's when it's seeing the floor. And if you look at it here, yeah, they're all concentrated right at the floor, but there's some speckles above the floor. And those are the ones that I got to figure out. And then, so that's my front sensor. Then I have a left sensor that pulls in more stuff. So it pulls in more information about the other walls and the junk around it. And you can see at the very...
Mike, turn off your front sensor so you see that other sensor. You turn it off. So
right.
Yeah, you can see the side sensor.
Right. And so it's yeah, so it's the side sensor that direction, and then I have another side sensor in the other direction. So I should be able to sense things below the LiDAR and avoid them. I just got to figure out how to not avoid the ground with all those speckles coming up. And I've just got these sensors to work, and I haven't really tuned them up. And when they give me a distance data, I just grab it. I don't say, is that a good piece of data? Because they give like intensity and values that says how much to trust it or not. I just take it. So I think I need to filter it on some of the data that the sensor gives me that says, hey, this is a trustworthy value or not so trusty. Maybe they'll get rid of the speckles. And so then if I turn the other sensor on, so I got a full 45 times 3 is 135 degree view. And okay, so that's my and then the yellow ball in the hallway at the very top of my screen there, that's the cone detector. And like I said, if you look at the image, there's a cone in the hall. Yeah. We turn the light on.
Question is typed in chat.
Yeah. So you can see the cone better because I turned the light on in the hall. And so the yellow ball at the top is the cone detected. So yeah, so I'm pretty pleased that my sensors are working. I just have to get them to work good, really good, so they don't give me false stuff.
Looks like Jim F wants to ask you a question, Mike.
Okay, I'm sorry, I'm not seeing the screen. So
Jim, can you go ahead?
I typed it in chat. I'm microphone shy. Anyhow, I'm microphone shy, but anyhow, what is the part numbers of the time of flight sensors you are using? I've seen 8x8 TOF sensors before, but I can't remember the part numbers.
Okay, let me
please type them in chat. Thank you.
Mm-hmm. Okay, so okay, I'll type it in chat. But
is this all running on like an NVIDIA board or a Raspberry Pi?
a Pi 5.
Okay.
Yeah.
Yeah, because I was also going to ask if you I thought maybe you're using an OAK camera for doing some of the depth. I'd seen on the you had an OD model.
Yeah, there's an OD camera, which is what you see here and what's detecting the cone.
Okay, so yeah, it's using the
images.
onboard vision.
Right.
Oh, perfect. Yeah, I got that's my next project. Oh, this is my next project is the OD light that I've had forever.
Yeah. So it's
Okay,
so it's everything is. I've seen the GPS put out coordinates, so I can. It's pretty useless inside the house, but it'll take it outside, and I'll try to work on GPS someday. But getting this stuff running is, is important too. So something I can do inside with the air conditioning. So, but okay, I'm gonna stop sharing this again.
It's great, Mike. Making good progress.
Thanks for the update, Mike.
Mhm.
Gold star. Excellent. So no other questions for Mike. Up next, we have Doug that wanted to share something.
Yeah, the two things. Wanted to let people know about the Robo Columbus mug design. I've seen some ideas flashed around, and it looks like it's coming along, and we should have a 2025 mug design here in a couple of weeks. So anyway, just to let you know that. And the other one is this. I'm going to share a screen here if I can remember how to do it. I think it's this one. There it is. Okay. All right. This came across my email the other day. This is DF Robot. This is an RTK positioning kit with low array for the United States. It's 915 megahertz, and it's way cheaper than I've seen it before. So this is pretty much the whole. You just buy the kit, put it together, and you have all the parts you need. You might want a ground plane for your antenna. See if I think they had a picture of it. Oh, wait a minute. I guess I got to go to that screen. Okay, let's see here. No, they had a picture of it set up somewhere. Oh, I guess this is kind of the idea. So, you get the radio is going to be talking to the radio antenna on your rover. So there is going to be a range limitation. It won't be as nice as the systems that have that are using a phone connection, because those could just call up Steve's RTK station and they'd be fine. You know what I mean? So this one, you actually got to set it up. But for things like Robo Columbus, it should work pretty good. Anyway, we'll see. I decided to go ahead and purchase this. And so in a couple of weeks, we'll see if it's worth looking at or not. All right, that was pretty much what I wanted to talk about.
If you're relying on LoRa, then you need line of sight. So
Right,
if you're going
that's right.
around the house, it might be a problem.
Well, that's that is a possibility. So because probably going to go around the house, but we'll see how it works. I want to. The solution is simpler than trying to hook up a phone and getting that to work. And but I missed last week, so I did not see how Scott's doing it. Can anybody update me on what Scott's doing? What's he's he was putting an RTK system on burp, I believe. I read the summary right.
He has an RTK on burp or belch,
Belch. Okay.
and that's he was getting that going, testing. And one of his questions, he was hoping you were there. So last week, his question was essentially, Paul had removed his GPS with his Raspberry Pi out of his robot in a cradle and carried that around the course to map out GPS coordinates. And he said that fit within the rules of not having your robot run the course prior to the competition.
I believe, otherwise you can, I believe the rules specifically say you can detach a module and run it around the course and bring it back and reattach it to your robot, but your robot itself can't run the course.
So what he is saying is, if he detaches the wheels from his robot, so now his robot can't roll, can he carry the robot around on the course?
I don't know. I think I got Kareem too. I don't know about that one. That one, I think I might have to say that's kind of like not in the spirit of the rules. Okay. But that's just my personal opinion on that. We're going to try and allow people to be successful as much as we can. So, but he's Scott. So,
Yes,
I think one of the questions that was brought up as well is the GPS coordinates that are used in the contest. They're determined how? Is it with an RTK GPS?
Okay. All right. If you read the rules, they mention that the coordinates can be, it's sort of like a green, what do they call it? If you go playing golf, they have a green, but they move the cup in the green and all around the green.
Yeah.
Okay. And the rules say that you're with, that they'll give you coordinates that are within 20 yards or something. Now, originally, the reason that was done was because we couldn't nail the exact point of where it was. We were using a 20 or 10 meter GPS to find the coordinate that we were given to people. So we said, well, if it's within 20 yards, that's okay, Now, so that rule is still in effect. But last year and probably this year, we actually used Steve's RTK system to nail the GPS coordinate of the cone down to like a millimeter or something. So the coordinates you get from Steve will be spot on, probably.
Okay. And that's the question I had for myself. Like, if you're relying on these coordinates for your robot and you don't have RTK GPS, at least that gives you, an accurate position of where the target should be.
Right. Yeah. Because the assumption is that you're not using GPS to touch the cone. You might get lucky and touch the cone with the GPS, but more likely you're using the GPS to get close to the cone where your end game kicks in.
Yeah, but my assumption was that if you're using the RTK GPS to give the coordinates of the cone, at least now that I know that it's not plus or minus 10 meters or whatever, it's going to be, here's the real location, and if my GPS can get me close enough to it, well, great.
No, that's what we're doing now. Okay. But I could see us actually reverting back, saying, okay, what we'll do is, we'll give you the RTK, we'll give you a coordinate that's within 10 yards.
Yeah,
Okay.
a regular
We-
GPS
well,
signal.
Yeah, we could go back to that because, we might not have, right now we got an RTK system station right there in the yard. So it's not, it's not hard to do. But if we moved it to, say, a park somewhere, it would be hard to do. We wouldn't necessarily have, well, I don't know. And another thing I should point out, this is a fundamental difference from Robo Columbus and Robo Magellan. In Robo Magellan, RTK is not allowed. So if you want to someday take your robot to Seattle and run it there, you got to have a non-RTK solution. But since we're actually trying to allow as much technology as possible into the contest, we allow RTK. But we don't allow differential. But then again, I don't think many people would have access to differential.
Well, Scott,
Why do we not allow differential? It's lower quality than
I know,
RTK.
I know. To force people to use RTK. No,
So-
actually, yeah. So what I'm trying to say
And the
is,
big bucks.
yeah. Yeah.
so Scott had a ground, like a metal plate under his antenna,
Yes.
and he said it made a great difference. And he also said for non RTK, it made a great difference too. Like he was able to like tighten it up a factor of 2, just using
I have, let's see if it's over here. Give me a second.
Yeah, that was my experience with a ground plane as well.
Hmm.
On regular.
No, it's in the pile somewhere, but I have a 6-inch, in my case, it's aluminum because I'm having it up on the staff. Or no, actually I don't. I actually have it on a separate staff. But it does help. It does help. Now, the bigger problem you have if you put that ground plane on your robot is that most people use a metal one, and they also have a magnet on the back of their patch antenna that they're sticking on there. And both of those things are going to screw up any compass you have anywhere.
But aluminum works just as well, and it doesn't have to be grounded. We were talking. We just needs to be there just to suppress, to manage the RF stuff.
Yeah, I ground mine, but you're right. And it's I get rid of my magnet. I opened it up and took the magnet out of the back of the patch antenna. So that it won't, because I'm hoping to possibly, I'm still out on it, but I do have a compass that seems to be accurate, and I might not use it for the whole thing. I might use the GPS while I'm running, and if I do have an RTK solution, I'll use it. But the compass, letting it run in the beginning and just say, okay, I'm actually pointed at 163 degrees or whatever it is, might be good. We'll see. I'm still polishing axles to get the wheels on, so we'll see how that goes.
Okay, next up, I'm going to try to play a video that Ed had. So I'm going to try to present a screen. Okay. So everybody see this?
Yes.
I don't know if the audio will come through, but
Well, you can use the captions.
To save everyone the hustle of taking out the trash, we built 20 running trash bins. Our studio is a mess. There's always garbage on the tables, on the floor, and the bins are always full. At first, I thought the problem was simply not enough trash cans, so I bought more. But for some reason, people still didn't bother. Then I had a thought, what if the trash bin catches trash mid-air, then empties itself automatically? Wouldn't that solve everything? To catch trash, there's 2 points. First, know where the trash will land. Second, get there fast. The second part's easier. We added 3 big motors and wheels under the bin, so we can move quickly. Nice move. But how does it know where the trash is? 12 years ago, someone online made something similar. He used to connect on the wall to detect trash, but that only works in a fixed zone. So instead, we put the camera on the bin so we can go anywhere it wants. Then we train a model to identify common types of trash. When it sees a trained object flying through the air, it sprints to intercept. After many rounds of fine-tuning by our engineers, it finally caught its first piece of trash.
Oh, cool.
With the basic function working, we created 3 specialized bins. One can mop the floor. Place rock, paper, scissors with you, make you feel invincible. One has a lid, so we can now
Practice rookie. That's baby stuff.
talk trash.
If you make it in, I'll eat my lid. Haha. Nice try, genius.
And then came the ultimate bin, the punishment bin, equipped it with a soft dart launcher. If someone litters, you can remote control it to fire a warning shot. Swap the dart for a laser pointer, then you've got a mobile cat toy. Link them all to the same remote, then you can take your bins for a walk. But what if they ran out of battery?
So hungry.
We made a rotating charging hub with magnetic contact points. The bins line up, roll in one by one, and snap into place to charge.
Seriously?
So now the throwing trash part is solved. What about emptying the trash automatically? We built this massive robo-arm trash bin. When a little bin shows up, it does this. Just kidding. We actually make this a Hesio mega bin. And we give each small bin a bag swapping mechanism. When a small bin approaches the big one, the big bin extends a clamp, lifts the back system, swing it over the mouth, then tightens to heated wires to seal and cut off the full part of the bag, which drops into the big bin. A fresh bag is pulled into place. But wait, how do the small bins even find the big one?
Now where's the big dude?
If you've been watching closely, you might have noticed our floor looks weird. Who uses black flooring? And what's that strip in the middle? Well, when everyone leaves and the lights goes off, this is what it looks like. We embedded LED strips under the floor and placed downward-facing cameras on each bin. Then we taught them to follow the light. So by programming the light trail, we can guide the bins one by one straight to the mega trash bin.
Should have been Sorcerer's Apprentice for this part.
Alright everyone, that's it for this video. Ever since we set up this system, our studio felt haunted every day. Thank you so much for watching. We are a DIY studio in China, makes weird stuff. Follow for more.
And it's pretty funny.
Pretty funny. It's cool. Now the big problem now is how do you empty out the big bin?
Hey, almost a year ago, I developed this table saw jig.
how do we stop presenting? There you go.
Yay.
Usually it has a stop presenting button, but I just presented the window for the video.
So we have a new contest.
I have a very serious question. How much of that was real and how much of it was AI?
That's what I was thinking.
I believe everything I see on video. Yeah, it's an interesting concept, but who wants to cut holes in their floor to put LED strips?
It'd be cool.
Yeah, but the more thing is, how many man hours do you think that it took to develop that? You know, what company's going to allow you to spend that much time solving how to take out trash? I mean, it might be a selling point, you know, otherwise you show that video, it shows that you have a certain skill, you know, certain level of skill, but it's
I
probably
think
very
the
expensive.
university probably spent millions developing the technology.
Yeah.
Did it say who? Well, I thought it was a private company, was it? Was it a university?
I didn't see.
Okay.
I think Tom's onto something.
I think they're a YouTube TikTok studio. I think they make their funding out of cool videos.
Mhm.
Right. AI generated videos. Yeah.
It was
Anyway,
well scripted though, wasn't it?
Yep.
Very entertaining. Okay.
So that was the end of our presenters tonight. Does anyone else have anything they'd like to present?
I guess the only thing I'm questioning is let everybody know November is going to be here very quickly.
Mm-hmm.
Before the recording, I was telling everybody that how I'm tied up until September 17th, and
Yeah.
on the 18th I can start full time.
Okay, cool. Yeah, well, I'm hoping to I made modifications to the frame that I was going to use, and they're taking a lot longer than I thought, but it's going to be better. So I'm kind of excited about that. So Scott didn't say he was bringing back Burp, right? He did say that. You're saying he did it on Belch.
I thought it was on Belch last week.
Okay, all right. I'm just curious.
So he had it looked like a black aluminum chassis made out of folded metal.
Yeah, four wheels.
Four wheels.
Yeah, that's not Burp. Burp is a tricycle, or not a tricycle. Two differentials with a rear wheel caster.
Yeah, this was definitely a four wheel robot.
Okay.
I do have a rule question. If you, on your first run, find the exact coordinates with RTK, I swear at some point you previously said you couldn't remember those between runs. Is that right or not?
Well, that would be kind of a push the edge of the rule set. The rule set says that you can learn. You can learn, okay? But if you said used RTK and then got your 9 points, you know what I mean? I'm not sure you could really say, well, okay, I learned that waypoint. You could strip out, on your second and third run, you could, anything you gained on the second run where you weren't using RTK or any log waypoints, you could do that. So, otherwise, you got 3 waypoints. There's the 3 waypoints and midpoints, 3 waypoints only, 1 waypoint, 0 waypoint, and 0 waypoint. So 0 waypoint, you're not told anything. You are allowed to point it towards the first cone if you can see it. And you obviously, the start line's not exactly at cone 3, but it's close. So, you kind of, all you're really trying to find is that third cone, wherever it is.
Well, if you're just pointing so there, are there two extra points available is what I sort of understand.
Okay.
How do they work?
If you stop and touch each cone, no matter how you do it, you get 9 points and you're considered having a perfect score. All right. But then you can take challenges, and the challenges actually can bring you up to, if you did one without GPS and 0 waypoints, without GPS and 3 waypoints, those would both get you 2 additional points and make you 11. But what happens on your mug is it'll say perfect score, 3-point way, 3 waypoint challenge, no GPS challenge. You see, so you get those, and you'd also probably, you'd be higher score. So you would, otherwise, if somebody raced around the track and got a perfect 9, but used multiple waypoints, and somebody did it with only 3 waypoints, the guy with only 3 waypoints, he's a 10, and he would be the winner.
So these 3 waypoints are the coordinates rough coordinates from GPS of the cones.
Right.
Okay.
Yeah. Otherwise, but you can't use any, otherwise,
Right.
you can walk the course in the beginning and say, okay, well, I don't have sufficient obstacle avoidance to get around this dude. So I'm going to map around. I'm going to have an intermediate waypoint to help me around this obstacle. All right. And that's okay, but that's like the lowest level. Okay. And the next level up is you say, I can't use any intermediate waypoints. I have 3 waypoints. I have to make it through the obstacles. I have to do whatever has to be done. And then the 0 waypoint is you're given nothing. You can't have any waypoints on your computer. Now, like I say, you can learn. So like if you decided to go for the 0 waypoint on the first run, everything that you learned on the first run, you could eliminate in your search pattern. You could say, well, it wasn't here. So you wouldn't have to search that same area on the second run or the third run. Okay.
So this is entirely about pre-run provided waypoints, whether it's by the course, by the judges' waypoints, or your own intermediate pre-planned waypoints. Those are the kinds of things you're talking about, but you're not excluding just using GPS. Like if I want to run with no waypoints, but I want to use GPS.
No, that's fine.
That's fine. So it's not about the technology. It's about
no.
what waypoints you start the run with that are not learned by the robot.
Right. And now you do bring up a point. I believe I think it just says no GPS. So that means no RTK, no nothing. You know what I mean? If let's say one case that's probably not very well defined is, let's say you use RTK. Okay. Still, if you decided to go for 0 waypoints, you would just know where it wasn't better. You know what I'm trying to say? So if you actually found it,
use RTK for like heading instead of a compass.
Right. Yeah. That could be, and that would be useful.
So that's not excluded.
Right now it isn't.
Okay, because the language does say no GPS, and it's not that specific about it means no GPS waypoints.
Yeah. Well, it means no GPS. The no GPS is a separate challenge. Okay. As many waypoints as you want, 3 waypoint only, and 0 waypoint. The 3 waypoint only and the 0 waypoint are challenges. They're not you can use GPS on either one of those, but there's an additional challenge of not using GPS. Okay, so that would be, otherwise a person might make intermediate waypoints. Right now, he has no GPS, but do it without any GPS, or otherwise totally dead reckoning. Okay, then he would get the no GPS challenge. Am I being clear, Kareem?
So, sort of. It's all
Okay,
right.
well,
We'll-
what I'm trying to
we'll
say
figure
is,
it out.
think of it, there's 3 challenges. Okay, besides the standard perfect score, okay, where you can go as many waypoints as you want. There's 3 challenges. One is with no GPS. Otherwise, if you run the course with no GPS, that's a challenge. If you run the course with GPS or without, and only use the 3 given waypoints, that's a challenge. If you use 0
Are
waypoints,
both of those worth 10?
you get a point for each challenge, I think. But since if you're
These are mutually exclusive to some degree.
that's the 3 waypoint and the 0 waypoint are mutually exclusive. That's why you can only get to 11. If you left your GPS on, it's normal, and you got a 3 waypoint only, you would get 10. Okay. If you
And what
went
do you get
with
if you only do no GPS?
10.
So that's going to be worth less than somebody who's cheating with GPS. RTK.
No, each one is worth a point. Each challenge is worth a point. Okay.
You mean on subsequent runs you can get different?
Well, okay. We trust people, so let's say you mapped out how you wanted to do it and you had 7 waypoints. Okay. And you missed all the obstacles. All right. And then you said, okay, I got my perfect score. I got 9 points. Now I want to try something more challenging. Okay. Well, you could do it where you limit yourself to only 3 waypoints. So you'd have to clean that out of your code. So all you had was 3 waypoints. And if you completed that, you would get a 10. Okay. If you cleared it all out and said, I'm going to do it with no waypoints, and you were successful, you have to be successful to get that extra point, you would get a 10. Again, because
so there is no 11.
Yes. So the 11 is if you take one of the either 3 point or the 0 point and don't use GPS, because the no GPS, you get a point. So you could get.
Well, if you're no GPS, what's the point of having any waypoints? You're automatically without waypoints.
Well, if you
Right?
had 3 if you had 3 waypoints, okay, and no GPS, you could do dead reckoning and obstacle avoidance, and
I see.
you could get it. You know what I mean? So,
but then angular headings, do they count as waypoints? Because they're not actual points. Like you still have to give it some idea of where to go from the starting line to the first cone. You're going to point it there, right? Presumably.
You could. We remember we said that if it's visible, you can point it.
Well, you're still going to know roughly where it is, even if it's not
That's
directly visible, right?
Right. You're going to say, yeah, it's kind of this way. You're not going to point it off 90 degrees or anything.
And you're also going to know where the second cone is relative to the first cone, angularly, roughly, right? You're gonna approach the first cone on whatever bearing you are from the starting line, and then you're going to say, I got to turn right.
Well, you're going to have to search at that point. Okay.
But you said it wouldn't be. It's not necessarily visible from that.
Right.
So now you're talking about a random walk around the property.
No. Okay. So if you think about it, I'm going to do. I'm going to let the GPS run. Okay.
Mhm.
I'm just going for a 0 waypoint. I know two things right off. I know roughly the direction of the first cone. And I also know roughly where the last cone is, because I'm on a start line that's next to the cone circle. You're not right at the cone, but you're close enough that if you came back to the start line, you would be close enough to probably search for the third cone, right? The home cone.
Yeah.
Okay, so the only one you're really having to find is the challenge cone, which you won't be able to see from either one of the other cones, because it's going to have obstacles in the way. You won't see it.
Yeah.
So you have to do, and now if you think about it, well, okay, I know on Steve's land that if they did what they did last year, I would have to turn to the right somewhere, because there's no more land on the left. Right?
I'm just saying you're going to have to provide some sort of hint. Otherwise, it can go off in any direction, start trying to find the cone, and we could be like following that robot for hours.
No. There's a time limit on the robot. But that's why we said you could learn. Otherwise, you could say, okay, the first guy goes off. I think it's going to be to the right. And I'm going to go search off to the right. And I never find the cone the first time, but I know where it isn't. Okay. It's not wherever I looked.
Okay.
So so you could say, go to the furthest of my search points, just run there. Okay. And then start doing, now it becomes like, how far away can you find the cone? You know what I mean? If you can see a cone at 30 yards, then, a stop and look probably worthwhile every once in a while. We haven't had anybody do it. So this is all.
I'm just wondering if anybody ever will. So based on the depth of that challenge seems like it's worth more than 1 point. But anyhow, so I'll ask for instance, I'm asking is if you as the coder gave it a hint that at the second cone, because you've already walked the course or you've run it in GPS mode before or something like that, you say at the second cone, you need to turn to whatever bearing in order to start off in the right direction to find the intermediate cone.
Well, some of this is
that a waypoint because you're now giving it some sort of direction?
My thought on that would be, it depends. Like if I went there and said, okay, I got my perfect 9, and I know that cone is 182 degrees from the first cone. Okay. That would be cheating.
So
but if you said, okay, when I get to the first cone, I know it's probably to my right. And so I turn 90 degrees or something. And then whatever heading that is, and I head that way, that's probably be legit. It's what a challenge what people make out of it. What we tried to do is raise otherwise there's headroom in this contest. Okay. A lot of us are still struggling to get 0.1. Okay. So, we just want that cup. Now, so getting a perfect 9, if you think about it, last time, Paul got one, right? Didn't Paul get it? Yeah, Paul got one, but he was the only one. Okay. And the time before that, I don't think anybody got a perfect 9. So getting a perfect 9 is still a challenge for most of us.
Sure.
You know what I mean? So, but someday, and probably, Scott might be on that way. You could probably do it. You get to the point where you say, and David Anderson David Anderson was very thought that our ability to make intermediate waypoints was not he said it was kind of cheating, you know what I mean? Otherwise, he was saying that you should be a 3-waypoint only, no intermediate things. But that's a harder challenge. And so, yeah, we've got that challenge. You can do it. And that's, of the 3 challenges that you can have, that's probably the easiest. You know, if you have a working obstacle avoidance.
Yep.
You know, but you know, it's like sometimes the course, even with good obstacle avoidance, you know, there's that thin wire fence that he has that's right above the lake. You know, Scott didn't want to. He didn't want to challenge. He just didn't want to attempt that. You know what I mean? Because he felt his robot would probably end up in the water. So, you know, instead of relying on his obstacle avoidance, you know, he added an additional waypoint. And that's probably the way you want to get on the board, is, you know, as high as you can.
Sure.
Mike's got you know, is looking to get a 9, and he's got a robot he's trying to make go 2 meters. 2 meters, Mike? 2 meters a second?
Yeah, straight course, yeah.
Yeah, so that's pretty damn fast. That's equivalent probably to what Scott's robot does, I think. I don't know. He's not gonna be.
Is that a jog?
2 meters.
Jog to keep up with it.
I think
Fast
so.
jog, yeah.
Fast
That's
jog.
a slow car ride.
Yeah. Yeah, you know. So that means when you hit something, though, you hit it hard. You know? So, but you know, like that, for example, you know, that single fence post that was right in front of the cone last year, that it caught Scott's. You know, it had plenty of room on both sides with this one little steel post sitting in the middle, and he whacked it right good. So
yeah, that was pernicious placement by the panel of judges.
no, this year it's got to be weirder.
All righty.
Okay. Yeah, because you know, we got some people that look like they're getting. Looks like it's going to be a challenge this time, so we'll see. So we might leave Steve's faded pink flamingo out there. Yeah, it looks kind of like a cone.
How many have signed up so far that you know of?
Well, we won't know until the day, because
Okay.
everybody, you know how that is. Everybody's, you know, it's the night before people will be making code changes. So, you know, you might break it on the last day. You know how that is, Mike, don't you? You've done that, yeah. So, anyway, we'll see how that goes. So, I mean, I'd love to see us, because, you know, to a certain extent, I think RTK is cheating. But will I use it? If this $160 solution works, then yeah, I'll probably use it. But you know, my intent is to eventually run in Robo Magellan. So I want a non-RTK solution sometime. But yeah, I think what, you know, with having Paul nail it so easily last time kind of, you know, made it kind of soured my RTK taste. But
do you know how many waypoints Paul used to get to the cones?
he must have used more than a few, because the reason why I say is because he had no bump. Well, no, I think he did have a bumper, but he had no
No obstacle avoidance.
No obstacle. Yes. And I'm not even sure he had a bumper. You know, he just drove up to the cone and stopped. Because I know on one of them he stopped short. And so anyway, I don't know what his coding was, but I know that one time in one of his runs he stopped short of a cone. So, but I'm
Thanks,
real
Doug.
intrigued.
I gotta head out, but thanks.
Okay. Okay.
Bye.
All right. Great.
Good question, Kareem.
Yeah.
Any other questions tonight?
How's that pie dog doing, David?
Yeah. Well, I remember like last week or so,
I haven't broken it yet, but it hasn't done a whole lot yet either.
So it hasn't walked off the table yet?
No, I haven't tried walking it on the table. I tried walking it on the floor.
Yeah.
I'm chicken.
Yeah.
Yeah, well, the sensors I have, they're the newest version from ST Micro. It's supposed to have better outdoor ambient tolerance. My new array, time of flight array sensors. And I was having a hard time finding a library. I found one, and all the documentation sort of implied that it only worked with an ESP32 or something like that. But I got tired of trying to get my ESP32 to work, and or work well with this. Yeah, it was doing some strange things with my Arduino environment, and then I said, okay, let me just try it on my RP2040, which is my go-to processor for my micros, and it worked. So
Well, that's good to know.
So now I got 2 cores, so I can run the front bumper sensors on one core and the rear ones on another core with its own I2C bus. Because at 10 frames or 10 readings per second, it took about 20 microseconds, 20 milliseconds to do the I2C transfer from one sensor. Wow. And so with 3 sensors, that's 60. So I'm out of time. So I'll do it with either two different boards or use both cores. So
yeah.
But I'm glad I can figure that out. So
yeah, especially if you're trying to go fast at 2 meters per second. 60 milliseconds is a long time. You know what I mean?
Well, but I'm doing a 10 hertz sample update rate. So so it gives me 60 milliseconds to collect the data and some milliseconds to transmit it over the serial port and stuff. Yeah, some overhead, and so I got some room to play to run some extra code and stuff like that. But I couldn't do all 2 sets of sensors with 1 core just because of the I2C. And I got the I2C running at 1 megahertz. So yeah.
So let's see here. Let's see where.
And to get the I2C to work at 1 megahertz, I'd put an I2C buffer on it because my wires are pretty long, and it was acting up. I looked at the scope and it was like oscillating. It's like it wasn't happy at all with the built-in buffer or I2C pins on the microcontrollers. So I put a really nice TI I2C buffer, I guess is what you call it, repeater buffer. So it gives a really good signal and has high quality drivers and the ability to break out of a lockup condition and stuff. So
yeah. Anyway, Pat, if we don't have anything to go, I'd say it's probably time. It's 9 o'clock.
Okay.
Y'all have a good week.
All right. Bye.
Okay, guys. See ya.